Welcome back, guys. In this video, I'll be taking a look at a vector addition problem. And the purpose of this video is to give you a bit more background on what we mean by resultant forces. So you would have seen a lot of problems with the method of joints videos regarding the resultant force for various truss members. So in this video, we're asked to determine the magnitude and direction of the resultant force for this. I guess you could think of it as two ropes attached to a wall, and one force is larger than the other force. I've labeled them as vectors, so that's vector A at 6 kilonewtons and vector B at 2 kilonewtons. So we're asked to determine what the resultant force would be. So if you picture two people pulling apart at this joint, I guess, where would be the resultant force? I think intuitively we could think, oh, maybe it's going to land about there if you try and balance those two forces. But let's do it mathematically and thoroughly. So let's pick a different color. So vector A, if I put it in matrix form, that's going to be, I need to know the x component of this vector, right? So if we're taking a look at it from this angle, it's going to be the x component here, isn't it? So our hypotenuse will be the 6 kilonewtons, and that's going to be a cos 60 degrees. We're referring to this component, this x component. And the x component for vector A, that's going to go in the negative x direction, isn't it? That way is negative. So I'll pop a negative in there. And we also want to know the y component. That's going to be the y component. That was the x component. This is now the y component. And that's also going in the negative y direction, isn't it? So, and that's the hypotenuse for this is also going to be 6. This time it's going to be sine 60. So that's vector A in matrix form. Let's add that to this vector here, vector B. What's our x component of this force? That's going to be the hypotenuse, so 2 cos 45 degrees. And that's going in the positive x direction. Positive x direction. And our y component, that's going in the negative y direction, isn't it? So that's just going to be negative 2 sine 45. Okay, and so that's vector B. And if we add these up, we're going to get our resultant force, isn't it? Aren't we? Resultant force, we add up the x components. So negative 6 cos 60 plus 2 cos 45. Put that in your calculator. You should get negative 1.59. And if you do the same for the y component of this resultant force, you'll get negative 6.61. Okay, so let's see if we can draw that in a Cartesian plane. So this is our positive y, positive x. So it's going to look something like negative 1, and then it's going to be a very skinny triangle, isn't it? Something like that, maybe. So that's our negative 1.59, and this is our negative 6.61. This here is going to be FR. Okay, so that's what it's going to look like. The question asks us to determine the magnitude as well as the direction, which is any vector really. But if we want to determine the magnitude, we just have to do a squared plus b squared, right, for these components of the triangle. FR magnitude equals the square root of negative 1.59 squared plus negative 6.61 squared, right? And that gives us 6.8 kilonewtons. Easy. And now let's determine this angle. So it asks us, I think we're going to go from the x-axis. This is the angle that we want, right? But to calculate that angle, it's just going to be 90, it's going to be this 90 degrees plus this phi of that triangle, isn't it? So let's calculate phi first. Phi will equal to arctan opposite 1.59 adjacent, which will be 6.61. That comes to 13.52 degrees. And to get theta, it's just going to be phi plus 90, isn't it? That 90 of this square here. So that's going to be, what's 90 plus 103 degrees? 0.5 actually, 103 degrees. 103.5 degrees.